Okay, this video is for day 3 geometry, relationship of angles in regular polygons. So the packet says we have worked with many angle relationships this week. Today we will try to discover some patterns that appear with these angle relationships. First, recall the formulas for the following. So the first thing we're going to do today is fill out this top piece of the packet, all with the general formulas for finding interior angle sum, each interior angle, exterior angle sum, each exterior angle, and number of diagonals. Then we'll do a couple examples, example 1 and 2 down here, and we'll see some things, some patterns that come up between the formulas and the relationship between the different ideas depending on which kind of polygon we're talking about. And then we will get to homework after that. So let's recall each of the formulas. Monday we talked about the interior angle sum, and we said that the interior angle sum is n minus 2 times 180 degrees. And remember, n is, and this will be constant throughout all of these examples, n is the number of sides or angles. N is the number of sides or angles. Remember that in all polygons, the number of sides and angles are going to be the same number, so you can think of it either way. Alright, so then, if that is our interior angle sum, for us to find each interior angle measure, we want to find the sum and divide it by how many angles there are in the polygon. So the sum will be found the same way, n minus 2 times 180. Remember, n is the number of sides, and if we need to divide that by the number of angles in the polygon, we need to divide that whole thing by n. And again, that's what we learned on Monday. Then yesterday, we talked about exterior angles and diagonals. We did a couple examples to explore what the exterior angle sum would be in each polygon, and we came up with the fact that the exterior angle sum is always 360 degrees. No matter if it's a triangle, a quadrilateral, a pentagon, a 50gon, a milliongon, all the exterior angles will always add up to 360 degrees. Now, moving on to the next one, if we want to find the measure of each exterior angle, then we need to divide that 360 by how many angles occur in the polygon. Remember, number of angles or number of sides, it's the same number, and that's always going to be n. So that's the number of angles in our polygon, 360 divided by n, and that will give us each exterior angle. And then finally, the last formula we talked about yesterday was the number of diagonals, unique diagonals that we could draw within our polygon. We said that the number of diagonals is n times n minus 3 divided by 2. And again, n is the number of sides or angles in the polygon. All right. Just for your information, we can draw some arrows here and show that this n applies for each and every one of these formulas where n appears. It's going to be the number of sides and angles in the polygon. All right. So because each angle or each formula deals with n and deals with the number of sides and angles in the polygon, it is always important to determine what our n is whenever we're trying to use one of these formulas. So let's do example 1. Find the following for a regular octagon. So we want to find each of what we just put formulas to. So the first thing we should do tells us we have an octagon. Let's determine what n is. An octagon has 8 sides, so n has to be 8. So for us to find our interior angle sum, we use the formula n minus 2 times 180. Plugging in 8 for n, we get 8 minus 2 times 180. 8 minus 2 is 6, and 6 times 180 is 1,080 degrees. All right, let's move on to each interior angle. We're still working with the octagon, so n still is 8. So that would be 8 minus 2 times 180. And then we have to go back and divide that by 8. We're replacing each n we see in the formula with the number of sides of our polygon. After throwing this into your calculator, you get 135 degrees. All right. For exterior angle sum, that's the one that we talked about never changes. The exterior angle sum, no matter what polygon we're looking at, is always going to be 360 degrees. Each exterior angle is going to be 360 divided by how many angles there are. In an octagon, we have 8 angles. So 360 divided by 8 is 45 degrees. And then finally, number of diagonals. Our formula is n times n minus 3 divided by 2. So we already determined n is 8, so 8 times 8 minus 3 divided by 2. Putting that in your calculator simplifies to 40 divided by 2, which is 20. Remember, number of diagonals would be the only one that's not a degree measure. Keep that in mind for your homework. All right. Now let's move on to example 2. Find the following for a regular 14-gon. So you can see that we want to find all of the same things. The only thing that's going to change is that we're finding this for a 14-gon instead of an octagon. On a 14-gon, n is going to be 14. So let's apply the formulas again. Interior angle sum, n minus 2 times 180. So that becomes 14 minus 2 times 180. And that is 2,160 degrees. Each exterior angle, remember, is the interior angle total sum divided by how many angles there are. So the angle sum is what we just did, so that will be 14 minus 2 times 180, and then divided by n again, which in this case is 14. Do that calculation and you get 154.3 degrees. Exterior angle sum, again, this is the one that never changes, so this is going to be 360 degrees. And then each exterior angle is going to be the sum, which is 360 degrees, divided by how many angles we have, which in a 14-gon is 14. And that is 25.7 degrees. Finally, the number of diagonals, n times n minus 3 divided by 2. That's 14 times 14 minus 3 divided by 2. That becomes 154 divided by 2, which equals 77. All right, now let's take a look at a couple things. The first thing I want to point out is this. Each exterior angle and each interior angle, so in the octagon example, 135 is each interior angle and 45 is each exterior angle. These two numbers within the same polygon are always going to add to 180 degrees. And you can see that occur in the 14-gon as well. 154.3 plus 25.7 adds to 180 degrees. So interior angles and exterior angles within the same polygon are always supplementary. Next, take a look at the interior angle sums in each. In the octagon, it is 1,080. In the 14-gon, it is 2,160. As number of sides increases, or in other words, as n gets bigger, these are going to increase as well. Same with each interior angle. If you look at the interior angle in an octagon and the interior angle in a 14-gon, that also increases. Which is different than each exterior angle. If you take a look at the exterior angles in an octagon compared to the exterior angles in a 14-gon, each individual angle becomes smaller as n gets bigger. So these decrease. And then finally, number of diagonals as n gets bigger also increases. Now, there's a lot of arrows and stuff, and I know this might be a little confusing, but I just wanted to point out a couple patterns that you will see as you complete your homework today. And they will help you answer some questions. They will help you fill out the table that you'll see a little bit faster, hopefully. And one thing that you'll notice on the homework as well is that other patterns arise and other things happen that you will notice and that hopefully you will make the connection with. And we can definitely talk more about it tomorrow when we kind of debrief on the lesson of today.